Welcome to Knowledge Share channel. In this video, we will be discussing about a power electronics based problem. So, as you all know, nowadays power electronics plays a very vital role in electric vehicles and as well in many of the converter applications like AC to DC, DC to DC, AC to AC and DC to AC. Many applications power electronics plays a very vital role. And nowadays power electronics gives more job opportunities to many students. Many recruiters are asking for power electronics based students. So in this regard, I have planned to post one problem, and this type of problem has been asked in many of the GATE question papers, and so I just want to post over here, and I just want to share the knowledge which I have in the chopper based problem. So I have just taken a chopper. Okay, so you know there are two types of chopper. One is the step up chopper, the other one is the step down chopper, and here I have taken the step down chopper based problem. Okay, so first the question will be something like this: a DC step down chopper has a resistive load of 10 ohms, and input voltage supply voltage, that is supply voltage is 200 volts, and when the chopper switch is on, its voltage drop is just 2 volt. Okay, and the chopping frequency is 1 kilohertz. And if the duty cycle is 50%, you know what is duty cycle? Okay, that is the on and off, that is the ratio of on time by total time is 50%. So what we have to determine is, we have to determine the average output voltage, RMS output voltage, and chopper efficiency, and as well effective input resistance of the chopper. So first you have to draw this diagram. Okay, so whatever the diagram, whatever the problem that has been asked, please draw the diagram first. Okay, so since it is DC, we are putting plus and minus here. The supply voltage given as 200 volts. From the problem you can see it is 200 volts, so it is 200 volts. So this diagram will not be given in the exam, so you have to draw by yourself. Okay, so this is a chopper. So what is chopper? Chopper is nothing but it is a switching device present between the source and load. It is a switching device present between the source and load, and by switching on and off continuously, you can control the output voltage that is being delivered to the load. So as we have discussed, that is when the on time is more, the output voltage will be high. When the on time is less, the output voltage will be less, and proportional to the output voltage, the output current also will be changing, or it will be inversely proportional. Actually the power delivered, and so that is a different concept. So now just you understand, we want to find only the output voltage, RMS voltage, and what is the chopper efficiency, and what is the resistance of the chopper. Is it clear? So I will just expand it. I will just expand this diagram. So here you can see that it is a 200 volts supply is given, and chopper is there. Okay, and the load is connected, the output voltage and output current is there. Okay, so this is the diagram which we have to draw, and moving on, and how to solve. Okay, so how to solve is, so here you can see that what are the given data. So the given data is supply voltage is 200 volts is given, resistance is 10 ohms is given, and V chopper is nothing but the voltage drop across the chopper. So it is nothing but 2 volt, and the duty ratio given is 0.5. So these are all the given data, and what we have to find is, we want to find the average output voltage, we want to find the RMS output voltage, and we want to find the chopper efficiency, as well as we want to find the input resistance of the chopper. Okay, so everything we have the formula. So for example, if you take the average output voltage, the formula is del into Vs minus Vch. Okay, so the average output voltage is given by del into Vs minus Vch. So what is this del actually? So del is nothing but the duty ratio. So normally we will be writing as the output voltage will be equal to del into Vs. Is it right? So output voltage is nothing but duty ratio into input voltage. But since the chopper voltage drop is also given, so we have to take into consideration. If the chopper voltage drop is not given, so theoretically it will be very less. Okay, when compared to the input voltage, chopper voltage drop is very less. So normally we will be ignoring. But if it is given in the problem, we have to take that chopper voltage into consideration. So normally the output voltage will be equal to del into Vs. So since the chopper voltage drop is also given, Vs minus Vch will be there. So here the formula is, what is del? Del is nothing but 0.5. That is, it is given as 50%. So if it is 50%, we have to take it as 0.5. If it is 20%, we have to take it as 0.2. If it is 70%, we have to take it as 0.7. So similarly, so I have taken it as 0.5. So the duty ratio is 0.5. The supply voltage is 200 minus 2. So you just calculate. So the output voltage will be exactly 99 volt. Okay. So if you operate the chopper at 0.5, that is 50% of the duty ratio, and if you give the input voltage of 200 volts, then the output voltage will be 99 volts. So by adjusting the duty ratio, you can adjust the output voltage. Is what the chopper concept. So then what is the value of RMS output voltage? What is the value of RMS output voltage? See here, there is a small difference. See, the formula for average output voltage is del into Vs, whereas for RMS output voltage it is root del into Vs. And since the chopper voltage is given, we have to subtract the chopper voltage from the supply voltage. So root del is nothing but 0.5. Well, yeah, so root of 0.5 into 200 minus 2. So you'll be getting the RMS voltage. So you can just see that the RMS voltage is quite higher when compared to the average output voltage. Okay. So you may ask that this DC is also having an RMS voltage because it is changing with respect to time. Okay. So similarly, what is chopper efficiency? So chopper efficiency. So in order to find the efficiency, always what is the formula for efficiency is nothing but output power by input power. So output power, that is efficiency, is output power by input power. So what is output power actually? That is del into V square by R. Yeah. So you know that the output power is given by del into V square by R. So here what is Vs? Vs is nothing but Vs minus Vch, because chopper voltage drop is also given. So Vs minus Vch to the whole square, del into Vs minus Vch to the whole square divided by R. So this is the power output. Then what is the power input? So you just see that there is a small difference. Okay, so power input is nothing but del into Vs into the Vs minus Vch by R. Okay, so here also two voltages are there, whereas one voltage del directly into Vs. The other voltages we are just subtracting this chopper voltage, because chopper will be switched on only during the on time. Yeah. So it is not switched on during the entire cycle of the duration. So it is switched on only during the on time. So in one case it is del into Vs, into the other cases the Vs minus Vch by R. So if you just substitute the parameters, that is 0.5 is nothing but the duty ratio, 200 is nothing but the supply voltage, and 2 is nothing but the chopper voltage. So you just substitute all this. So you will be getting 1960.2 watts. And similarly, what is this supply power? Supply power, that is input power is never. So you just substitute here. So finally, you will be getting 1980. So you are supplying 1980 watts, whereas only 1960 watts is doing the useful output. So here you can see that the efficiency of the chopper is 1960.2 divided by 1980, which is nothing but 90%. So it's a very nice device, is it right? So you're getting 99% efficiency. It's good. Yeah. So any device which is giving 99% is really great. Is it right? So because so that's the advantage of chopper actually. So normally the efficiency of the chopper will be always higher than 95. Whereas if you use the resistance based control, it will be less than 60 or less than 40 or something like that. So that's why we use power electronics nowadays in order to control the output voltage. Is it right? So by using the resistance also you can control the output voltage. But when you do so, what is going to happen is the efficiency will be dropped down to a very less value. Hence in modern days we are using power electronics to control the output voltage. So the next thing what we have to find is effective input resistance. So it's a very simple formula. The effective input resistance is nothing but 1 by del into R. So what is 1 by del into R? So 1 by del into R is nothing but 1 by 0.5 into the resistance value is 10. So you'll be getting 20 ohms. So you can see that the input resistance is 20 ohms. Is it right? So that's all from now. So this is the overall picture of the entire problem which we have solved. So I found out the average output voltage is 99 volt, the RMS output voltage is 140 volts. Similarly, the chopper efficiency is 99% and the input resistance of the chopper is 20 ohms. So it's a very important question in most of the gate papers and most of the power electronics question papers. I hope this video is I've shared clearly how to solve this problem. Okay. So thank you very much for this opportunity, and if you really like this content, please give a thumbs up, and if you have any doubts also you can just comment, and if you really feel that you can share to your friends, please share it to it, and if you really like the contents which I post in this channel, give subscribe, press the subscribe button in order to have in order to just have a small motivation of doing many such videos in future. Thank you.